Kia ora koutou, Reese from QuickSense here, and today we're looking at direct proportion. In this question, we are told that some variable A is proportional to some other variable B, and then we're given some values. So when A is 3, B is equal to 6, and it's asking us for the value of B when A is 5. So let's begin by writing down a general formula for proportionality. It's saying that A is proportional to B. Okay, we know that as A increases, B is going to increase by some factor, and that factor is normally referred to as K. It's a scaling factor. So what we're going to do now is substitute in these values to determine what K is before looking at what happens to B when A is 5. So I've got A equals 3. So 3 is equal to, because now I have some actual figures, K times B, which is 6. So A is 3, B here is 6. So we get 3 equals 6K. I divide both sides by 6, and I get K equal to 3 divided by 6, half. How do we use this? Well, now let's go back to the general equation. But now we know what K is, right? We know the scale factor, as it were. So K is equal to half, right? How is A proportional? Well, we can find it using this here. So if A equals 5, B is equal to, well, we divide both sides by half. 5 divided by half is 10, so B is equal to 10. Okay, in this question, it's a little bit more wordy, so we're going to have to be careful to pull out the relevant information. The height of a building is proportional to the square of the time taken by a rock thrown from the top of the building to hit the ground. All right, so the height is proportional, and you can write proportionality in a couple of different ways, and I'll show you how in a moment. But H, the height, is proportional to the square of the time. Okay, another way you can write this is with this little figure here, but I'm not good at consistently writing that, so I prefer the little tilde. All right, so let's keep going with the left-hand side. Given that a rock thrown from the top of a 100-meter tall building took 5 seconds. So the height is 100, and that's equal to some scale factor times the time, which is 5 seconds squared. So again, we have 100-meter tall building. We have 5 seconds. All right, so here's our time. Here's the size of our building. And we need to figure out what K is in order to solve the question, which is, what is the height of a building from which a stone took 10 seconds to reach the ground? Okay, so let's solve for K. Well, we use bed mass. 5 times 5, 25. Can divide both sides by that 25 and get K is equal to 4. Awesome. Now with this in mind, we can go back to our more general equation where the height is equal to K being 4 times the time squared. In this instance, we're trying to find the height of a building, and the stone took 10 seconds. All right, so this is 4 times 10 squared, 100, which is equal to 400. So the height is equal to 400 meters.